Today we start with Coaty, a Siemens open source project managed by Markus and Hubertus. And thank you for being here. The stage is yours.
So good morning, everyone. Thank you, Roger, for the kind introduction. I hope everyone is back on track after yesterday evening and everyone is feeling fine. So I'm here today with Hubertus. We are from Siemens Technology, and we have the pleasure to give you a short introduction on Coaty and why it makes sense to publish open source for research and innovation projects. So what will it be about? It will be about Coaty, it will be about open source software, and we will talk about innovation and research projects. But we will not talk about code, not about architectures, but we will talk about this more than 5 years of journey we had with this topic and give you some insights into why we went open source, what was the advantage, how we work, and why it is kind of for us a success story. So that's what we hope you understand at the end, and where you might get the one or the other insight you can take away maybe for some projects you have. So let's start with the overall evolution of Coaty as open source. So at the beginning, there was an internal research project. We had a certain technical demand, which could not be fulfilled at this point in time with stuff we could find. And at this point was also the starting time in around 2015, 2016, where also this whole inner source topic really established. And we said, okay, let's do it inner source. It makes sense for our research project also. So we started with Coaty framework for technical demand as inner source. Then at a certain point, we had identified that this is also something, because this technical demand was not fulfilled. It's also kind of a research stream we should establish. I will talk a bit more about this later. So it's the research about collaborative IoT. And some colleagues told us, oh, okay, after explanation, it's kind of something like the Tinder for the industrial IoT. So this is not my printed term. It's really a colleague who told us from, I think it was from DI, who said, yeah, it sounds like you're doing Tinder for industrial IoT. And that was the time also we had a public funded project, which was in a totally different direction like the initial project, but we found out that this is really something we could use for industrial IoT in general. And to ease cooperation with the other partners in this public funded project, we said, okay, after talking to business units, the differentiating factor is not Coaty, but what we do with it. So we can do it open source. So we had an agreement and we just published it. And now we are on this last step. Right now we have a couple of public funded research projects, or also in the pipeline some projects. We have some product innovation projects with business partners internally in Siemens, and we have multiple OSS projects. So we came from the technical demand and got into kind of even a complete portfolio, or it's kind of an ecosystem where business, research, and also open source kind of work closely together. So a bit more about open source framework Coaty. So what are the driving factors and the requirements for it? So first of all, you need a software project demand. So it should make sense what you do. So it should have some use. It's not just for fun. Then we needed a kind of a collaboration demand. So public funded project, working with business units, working with Siemens customers makes sense if it's not the core business. And we need this correlates kind of, we needed a project setup which supports this whole stuff. So where it really could be done as open source and where it does not open any IP. The other thing, if you decide then to do it, you need a collaboration and publication model. So how do you work with this OSS? So do you go to a foundation, build up a community, try to push it with contributors, or do it on your own? You need a publication infrastructure. So are you using GitLab? Are you using GitHub? Do you have something on your own? And very important, you need to kind of have continuity in the project. So you need to have some kind of financing. And this all kind of relates together, and these are the different aspects. We will put some focus points on it during the presentation, what we will talk about. So let's start with our initial project. A lot of text, but I will summarize it. So that was the initial research project. It was called Digital Worker. And it was really a research project where we said, okay, there are so many variables around, Apple Watches, smart textile, mobile phones, tablets, classes, whatever. Let's go to our factories and discuss with them where we can help them to use this technology in the factory floors. So it should be kind of a support for all the kind of human workers inside a factory or in general industrial assets. And the target was really then to build kind of a generalized platform where I can have a universal access to information and that works with the existing systems. Another parameter there was we wanted to establish the whole thing together with the factories or with the partners there. And so it should be kind of co-creation, living labs, discussing also really from the blue-collar workers up to the industrial engineering, up to the work council and whatever. And what happened then, we went to, I think, 12, 14 factory sites of Siemens, discussed with them, and what we found was actually we had a tremendous amount of heterogeneity. So from both the infrastructure, no Siemens factory site is comparable with the other. It's really, and Siemens is good in this, that it is kind of standardized, but then they buy a new elevator there, which has a different interface, whatever, so it was a mess for us. The second thing was, as we were quite open regarding the devices to use there, we had a large amount of devices to be supported, really from the watch up to edge devices, where we host some services, cloud services. We had the SAP systems, we had third-party systems, and the next step was, okay, we had also tremendous amount of use cases and scenarios. So, and we had two other limiting factors. The first thing was we wanted to quickly build tangible prototypes. So go there and show them what the idea or the concept is. So we need to be quick in building something or rebuilding something. And the other thing was we had limited project resources. So I think at the beginning we started with 5, 6 people and it burned down to 3 to 4 as core team. And so we had a big challenge how to handle this. So we came up with all these first insights and the plans. And then we had to think about, okay, how can we handle this? Then we searched for some frameworks. We couldn't actually find something which would support us to have kind of a continuous reconfiguration of these prototypes. We wanted to decouple the functional components so that we can both iteratively grow the architecture and also the use cases we have. But all this, there was nothing which supported us. And so basically we went one step back and we said, okay, let's focus 3 to 4 weeks together and build kind of architecture and a framework where we can, which supports actually our use case. And that's actually where Coaty came from. So we wanted to make these different systems able to interact without kind of a configuration setup. And so basically at the end, we had a large set of reusable components and tangible prototypes. We have 2 videos if someone is interested afterwards from this 2017, I think, or 3 videos even, which we can show, which are showing some of stuff. We did some living labs with Siemens factory, so we went there 4 o'clock in the morning, started the first shift with the guys there, really from blue collars to industrial engineering, work council, factory lead. It was at this time, I think the most intense one was the one in Amberg. And basically at the end, we had the first version of Coaty. But as said, also after this project kind of ended because of some organizational stuff, we found out that there's a large reuse potential because this problem you have a lot in future architectures. So that's why this new research stream came up as collaborative IoT. I will talk a bit more about this also later on. And Coaty was an enabler for us to further research it, but we also managed to have this in the quality that you can even put this open source framework into production if you want. So a lot talked about Coaty. What is Coaty? I will also not go in detail from a technical perspective, but more from the idea behind it. And basically our reference model were humans and teams and society. So basically humans are basically autonomous. They interact with each other. They form groups to fulfill tasks. They dissolve groups again if the task is fulfilled. They get information on demand. They collect information. So all this kind of concept was the basis how to structure the framework. So having independent agents which you could put to your components, system components, services, and make them able to interact together. So basically, oops, much too fast. We wanted to have any-to-any interaction. We wanted to have a loose coupling between the systems. We assume that we target autonomous systems, and we have this collaborative task. And we wanted to actually support, and so that's the basic vision behind it, this paradigm shift from this hierarchical architectures to a more decentralized base architecture where we can both have centralized and decentralized applications. And that's basically the idea behind Coaty, to enable the interaction in this system of autonomous systems. So it's a programming framework to test the systems, but also if you want to bring it to the next step to get into a product, you can also use it. So maybe a bit more to the projects. So that's basically how it looks like. So we started basically with the digital worker project. We had a couple of funded projects, CREST, and we had a lot of cooperation with the technical university in this iPractica. We built a lot of tangible prototypes there. So there was also a lot of articles about Simoji, Bazaar, and whatever. We had this Pebbles project, which was done by another technology field, which was about decentralized energy marketplaces, and we have this currently running FlowPro project. In parallel, we established this inner source open source stream. So we started with inner source, went public with Coaty 1, Coaty 2, Coaty Swift. Then in one of our projects, we identified we need this VDA 50/50 standard for for fleet management of HEVs. So we needed to implement it. So we also made it open source, and we have new projects coming up. So we have a TypeScript implementation for Raft, which we need in one of our projects. We want to make this public. We are also looking at a gRPC Coaty gateway. We are also looking at gRPC for pub subsystems, because that's a base layer for our Coaty, that we have a pub subsystem below. So we are coming up with more, which is in progress. And the interesting thing is that we also have in this middle stream that we have really with our business units projects where we get both insights from the open source or inputs from the open source, but also from the research project. And so this is kind of an ecosystem which continuously, you get ideas from here, you get ideas from here, you get components from here, and this works actually pretty well. So that was kind of an interesting, how should I say, setup that we could establish from this initial technical demand and at the beginning, for some people, weird idea to go open source. We could kind of have this whole ecosystem, which is actually only possible because we did this open source thing. Then I will look at some example for the project. So that's one Pebbles. So this is something I was initially involved, but then some other colleagues continued in another technology field, and it was about managing decentralized energy systems. They built up a local marketplace, so it was about that they could trade energy in a village or in a region in a decentralized manner, so not on this central market. I don't know the name, but it's just so that really the neighbors can trade between each other. And they used Coaty there to build a standardized connector for all the prosumers, consumers, producers, the measurement devices, the controlling devices. Coaty was kind of the interaction framework to enable this. And it was also here the big advantage was the design of Coaty, that they could start with a quick start with initial system, so that it was something working, and they could continuously add stuff. So like, for example, this persistency layer or the analytics layer was only added after actually the other system was set up. So this is kind of a core concept there. And again, here the open source benefit was we had immediate ease of cooperation with our external partners, as the USB was actually here in the marketplace, which is kind of Siemens IP, but really the others could immediately also participate, starting from Fraunhofer to some Allgäuer Überlandwerk, whatever. That was one approach, but our lead topic is actually self-organizing production and logistics. There we have both two funded projects and also one with, or two projects with Siemens BUs in this sense. And the nice thing about this, we could show the autonomy here, because this HEVs are moving autonomously, so you see immediately the autonomy of the systems. And here is about putting a lot of this centralized coordination functions we have right now in the central fleet management, we want to put it down to the actual devices. So both from the task requesting systems, but also from the actual transport robots. And yeah, here again, Coaty was the induction framework for all this. We were able to manage the heterogeneity we had there, because the requester could be, for example, a human for such a transport. It could also be a SAP system. It could be a machine. And all this stuff we could manage with this, and we can have multiple types of HEVs there. And yeah, on top of the Coaty here, we built some decentralized coordination functions. So there are auction mechanisms to decide which HEV to take over. We are currently looking in deadlock prevention concepts which work in a decentralized manner, but this is all only possible because we have this base layer where we can enable this interaction of this kind of decentralized setup. And here, I can talk even more about the open source benefits. Here, the good thing was, starting actually with the GRASP project, we got in direct contact to Siemens customers and also Siemens partners. And so the Coaty framework was kind of a way also to communicate and discuss with them, because we could offer something which was not kind of already something we need to sell. And we could get ideas, discussions in a very open manner, which then basically led to the fact that the business unit could take over this lead we generated there to get in a deeper cooperation. Sure.
May I ask a question?
Sure.
So I'm just curious whether I understood everything correctly. So you're saying you have these autonomous devices which
Yes.
are automatic or autonomous, but it could also be human beings, and Coaty is used to, well, to do the coordination between all of them. So would that mean that the human being has then a device and gets a notification by another machine what the human being has to do?
That could be an application you build, but Coaty is the interaction framework, not the interaction framework between the systems. So whatever application you build on top, it could be like you said, but typically it's the other way around, that I say, okay, I've finished my box here, send me the best fitting HEV now.
Okay,
But you, of course, you have a device, you have your smartphone, you have a smartwatch, and Coaty is enabling the communication with the system in a decentralized way. Yeah. So you, in fact, you say, okay, I have a box here with, I have an e-pallet or whatever here, and I want to get it transported from A to B.
Okay.
And I just say this like this via Coaty, using Coaty, and then all the HEVs will get this request, and they will have an auction and decide who will take over. So they will give bids. It's like an auction mechanism, for example.
Okay, but so once again, if it would be a bad science fiction movie, then the machine could control the humans.
Yes.
Just as a bad example.
You can build this application with it.
You,
Okay.
you could build it.
Thanks.
We should discuss afterwards how to make it come true. Yeah, so that's what I said. So here again, also the nice thing was that we can really, as we had again this concentration point of this open source, this kind of also made it possible to directly transfer research results in this business innovation project, and also some ideas from the one thing to the other. So it's also kind of a de facto standard what we created here for our projects, which helped us a lot to exchange stuff in between. Yeah, so then some other things. So the way of working, I said before, we had a lot of discussions what to do with this open source project. Should we keep it like it is right now, GitHub, we are mentioning our own, we are changing whatever we want, or should we go to Eclipse Foundation or Linux Foundation or something like this? And we were quite unsure at the beginning, but then we had a lot of discussions. We also talked to some guys from, I think, especially Eclipse Foundation. But at the end, it has two basic streams. So the one thing is really, if you publish on your own, you want to basically make your work available for others, and you want to ease cooperation and co-creation based on your work. And the other thing, if you go to the foundation, it's more like you focus on the open source software itself, And you want to grow this, you want to get contributors, you want to, so that's then the core of yours. You build a community around it, and you want to get the publication support. So that's, for us, it were completely different objectives. For us, it was a decision then to publish for now only on our own, because we don't have the key objective to work primarily on Coaty. We work more or less on the things where we use Coaty on for. So we are not working on Coaty per se, but Coaty is for us kind of an enabler for different stuff. So that's why we decided to keep this for publish on our own. And the other thing what we found out was that, okay, if we want to go to Eclipse Foundation or Linux Foundation, it's a significant effort to go there. So we are not this large team, and we don't have the resources to really do the community building there. So we said, okay, for us, that makes at the current point no sense, but it's nothing which is written into stone. It's more like right now, it's the better way for us. But if we, for example, see that Coaty, whatever, gets some significant contributions from outside, we see that there is some advantage, we would immediately revisit it again. And I think that's the important thing here. It's just for now, we say, okay, we keep it like it is, see what happens, and if it fits, we go to one of the foundations. And I think that's the point where I hand over to Hubertus, and he will give some insights on.
So let me share some experience about using Coaty or introducing Coaty, more on the level of regarding contributions, regarding maintenance and security concerns. Well, Coaty works, open source works like a boomerang for us. That's our experience. So you throw it out, you throw the software on GitHub, publish it, and you will get feedback, new contacts, or even opportunities for business projects over time, all the time, 6 years now. And primarily, of course, we have direct contact with external users we don't even know about. Aside from all our project partners, of course, where we make our project with. The second thing is more interesting. So we are also publishing third-party stuff, so press releases from Siemens, for example, or doing it on Heise Online, or from public funding projects or citations. So we get back contact with Siemens business units we didn't know, and they come to us and tell us, how we read about Coaty in a paper or whatever, what it is, can we do it, can we use it for our use case? This is very funny. And then last thing is, even we get contact with our business units by external partners. So, for example, we have some contact with external partner was working with Siemens sales in Hong Kong or US or in Hamburg. We didn't even know that they exist, Siemens sales in Hamburg or something like this. So, and we get contact with those business units involved just by publishing open source. So this is very interesting, and the advice is, if you want to get in touch with potential users, you should just promote your open source. Not only publish it, but also promote it. Okay. So next point, contributions. Yeah, it's like the motto, eat your own dog food for us. So we don't rely much on contributions, on external contributions. Most of this, what we are doing, comes out of our own projects with Coaty, with our partners. So most features and most issues we have. And Coaty itself is used by external users, of course, but mostly they use it as it is. Coaty is well documented. We have a huge developer guide, and we have a huge suite of examples, running examples. So it's very easy to get into. The learning curve is low, and we don't get much open issues from them. If there are issues, mostly it's questions. If it's about questions, how can you do this? Is it the right way to do it? But it's not really Coaty errors. It's few Coaty errors from this regard. And a very critical thing is we of course do upstream contributions to our dependencies, to our direct dependencies. I come to the point dependency management later, but it's very crucial that our base is sound and works. And as Markus told us, so Coaty is based on a pub/sub system, and publish-subscribe communication layer is abstracted by Coaty. So we have so-called communication bindings. You can plug in any pub/sub system you like, be it MQTT, be it DDS, be it WAMP, or peer-to-peer, so decentralized peer-to-peer. So you choose the transport layer, but of course the transport layer is a dependency and must be sound, and we do a lot of upstream contributions regarding bug fixes. Not so much new features, but bug fixes, because this layer is usually standardized, so we don't have any feature requests and stuff. So coming to the point of maintenance, yeah, it's like the Groundhog Day movie you all know. It's every day and every day it's the same thing. So you get you get some pop-up. You go to work today. You start your laptop up and you get some issues about dependencies of a project. And the thing is, Coaty is the reference implementation is implemented with TypeScript and JavaScript. So it works on any platform. It runs in browser and in Node.js. And the JavaScript platform is a huge system of packages. Small packages, large packages, thousands, millions of packages. Many of them are outdated, not yet maintained, and so it's a huge system, huger than in any other programming language. And there's a phenomenon which is called Npm Dependency Hull. And Dependency Hull is that your open source in JavaScript, so Coaty, is depending on a huge hierarchy of dependencies, but you cannot control these dependencies. So you have the direct dependencies you can choose, but then you have sub-dependencies and sub-dependencies. And this is a huge tree of dependencies. And it's even the case that you have sub-dependencies at any level with multiple versions of the same package, because the parent dependencies specifies version 1 and the other parent dependencies on the same level specifies version 2 or 3. So it might be the case you have a dependency to package X 10 times. So it's a huge thing, and the problem with Npm Dependency Hull is you cannot control the dependencies directly. What you can do is wait for patches to be released, of course, or you can open pull requests. It's GitHub, it's pull requests, merge requests on GitLab, and wait for them to be accepted in a timely manner, which is sometimes not a day or a week, maybe a month. And another thing is all those packages are versioned with a concept called semantic versioning. So you have a major version, minor version, patch version. If you make patches, you increment the patch version. If you make new features, you increment the minor version. If you make breaking changes, you increment the major version. And there are many dependencies which just violate this rule, and they introduce breaking changes in a patch or in a minor version. And this leads to the case that your system might break at runtime at any point in time. You know? Okay. So this means you cannot just simply upgrade your dependencies every day or so when a new version pops up. You always have to make regression testing, all your testing stuff, and you have to do not only unit tests but also end-to-end tests, component tests, everything to be somewhere safe. So this is not a problem with GitHub per se. This is a problem with the ecosystem of JavaScript. And there's also another thing. Yes, regarding maintenance. So what you can control a bit is your direct dependencies. You can choose them. And sometimes you have alternatives. for example, MQDT. There are two alternatives for an MQDT client, which is the famous PAHO client you may know from Eclipse Foundation, and one which is called MQDT.js. And so which one would you take if you look at these snapshots? What are the criteria to choose your direct dependencies? And so one thing you shouldn't count on is the number of stars and likes and the popularity alone. Because in this case, you would have 6 years ago, this is now, but 6 years ago, PAHO, of course, was much more popular regarding downloads and stuff as the MQDT.js, because it was hosted by Eclipse Foundation. And so you should look at the open issues, critical open issues, not the questions, but really the critical bugs. You should look at pull requests. Are they really handled in a timely manner? You should look at the version publication interval. Is it 1 year, or is it a month or a day? And what I will do always, I will always look at the code base, make a code quality review, and look how it is implemented. And you can also look, of course, at the dependencies of the dependency, if they are sound. So are they using, if someone is using Lodash today, forget it, because it's not normal. It's always, Lodash is part of modern JavaScript, but if you use JavaScript from 10 years ago, you need Lodash, but today not. So you should keep your direct dependencies to a minimum, and you should always look at this. And if you today, we see PAHO is dead. Yeah, PAHO is dead in effect, and this one is still running well, maintained, supported. And I choose, in this case, we choose MQDT.js, but because of the code base. So the stars were lower, all the things, the code base was the critical thing, because the power quality was not really good.
What about the license?
License is also a good a point. Yeah, that's a good point.
We are MIT licensed.
Yeah, we always prefer MIT or BSD or things like this. Eclipse, this is the Eclipse Foundation license. I don't know, would also be okay. Yes, license is also a good point, of course. We don't do something like dual licenses, so we don't have a partial thing. For the reason Markus explained, we will use it with partners, so we don't have this option for commercial use and non-commercial use. So we all publish by MIT license. So everybody can, but this is a decision we have done 6 years ago. Last point, this is a specific thing to GitHub, security auditing. This is a good thing in general, but it's also like the Groundhog Day movie. You can do it daily. It's never ending, it's time consuming. So GitHub, it's over the last month or year, so this is more modern, they have 4 tools to support security vulnerabilities in your code, so you can get support for this. The first 3 of them concern your own repository. So you have something like a security policy, so you can define in the document how users should report security flaws, weaknesses in your project. It's not, you shouldn't open an issue usually, because everybody could use the information to hack your system. You should do it on a private channel usually. So this you can define in the security policy document. And they have some security advisories, so you can discuss security issues with the other maintainers of your project. So it's a thing of admin. You have to have admin rights to be in this group. And finally, you can also publish, of course, fixes, so CVEs, and publish new releases. You can do this all in a GitHub workflow. And there's also a thing, we never used it currently, it's code scanning alert, so you have some tools which look over your code and find some coding errors. But the most important one,
did you ever get any reports about the security from external?
No, not yet. But we get hundreds of thousands every day. Every day we get those dependency alerts because we have enabled Dependabot. It's a bot, and the bot checks your dependencies on any level and looks if there are any open CVEs for this dependency, and if there's a patch version, you get notified. And you have the choice to let the bot automatically fix those errors by just what the bot does, it just increments the version number, the patch version number usually, in your package log file. But so this is a shortcut, because usually if there's a security vulnerability in your sub dependency, you have to wait for them to be fixed by the sub dependency maintainer. You have to wait for it to be published by the sub dependency maintainer. You have to wait for the sub maintainer, the parent dependency, to integrate the new version in his dependencies and publish it, make a new release, and then you have to wait for the sub maintainer and up. And if all this is done, you can just publish a new version. And the Dependabot makes a shortcut for this, because it just goes to your package log and bumps to a non-vulnerable version, if it's possible regarding semantic versioning rules. But I told you in the last slide, version bumping could introduce breaking changes because of violation of the semantic versioning rule. So this could break your system. So don't let we have the option, we don't let the Dependabot do automatic fixes. But we get notified every day. You start up your laptop, you get notified, new ones. It's a continuous thing you cannot get rid of. It's just there. Yes?
I've heard of that before, and I'm familiar with dependency alerts. Sometimes they are very creative. They tell you to use an alpha version. The maintainer would say don't use it, but GitHub doesn't recognize this. But my basic question is, now that you've seen what kind of situation we have with all NPM dependencies, if you would have the chance to restart Coaty again, would you still use JavaScript or TypeScript to do all of this, or would you recommend another ecosystem?
I would do it again, definitely. But we start. So, Timo. So we didn't start with JavaScript. We started with TypeScript. TypeScript was a very new kid on the block, 2.16. And we started with it, and it never used JavaScript pure. Always used TypeScript. TypeScript it's the best thing Microsoft ever did, definitely. Besides VS Code, it's also open source. so in this regard, if you look at VS Code, the contributions, it's fantastic what they do. And so we use TypeScript and VS Code, those two in common, of course. And TypeScript, you get all the benefits from a statically typed language, like C#. TypeScript is C#. And you get all the benefit from the not dynamically typed languages like JavaScript. So it's the best of both worlds. And it helps a lot because you have a compiler, and the compiler tells you when something is wrong at compile time, not only at runtime. So yes, I would choose it again. Dependency Hull, you have to live with it. And my advice is keep your direct dependencies to a minimum. Coaty has 10 dependencies, direct ones. And it has the whole tree of dependencies is 100, the whole. And these are the dependencies you use at runtime. There are also the development dependencies. We have 24 development dependencies, which is also pretty low. And they blow up to a tree of 600 in total. So all in all, we have 700 dependencies, but at runtime, we have 100. That's okay. The other ones, development dependencies, are not that crucial because they won't break your system at runtime. It's just the compiler, the build system, release system, and so on.
Maybe to add one comment on this, if we would use it again, I would definitely say also yes, just also because of the limited resources we have, because we want to use it both on services, so kind of on an edge device or in the cloud, but also use it in the browser, also use it on mobile devices, also use it wherever we want, and so we only have one code base to maintain.
Yeah.
That was actually at this point in time also the primary reason, because we had to get quickly running. And so that was the only language which supported us the full number of devices we needed.
Yeah.
And the good thing is even we can run a full Coaty agent actually in the browser.
Yeah.
So we don't need a backend for it. So it can directly connect to this kind of network we built up there.
Yeah.
This overlay network.
And later on to 2018, we built a Coaty Swift version. So the Coaty TypeScript version is the reference implementation. And we also have built a Coaty Swift version, which is used for our iOS projects, for iPads and things like these.
Yeah.
Yes. Okay, so I'm finished with this. And
yeah, maybe to sum up a bit, so why we published OSS to drive industrial research and innovation projects. So it's maybe a bit different than others using open source or publish open source or do contributions. So we come from this research and innovation project perspective. Overall, for us, it was a success story because of one thing, we couldn't identify any major downsides. Okay, it's a bit more effort to go public to check all this stuff, what Hubertus just explained before. But we were able to strengthen and speed up our research and innovation projects by using this approach, and was also very valuable was also in discussion then with going to the business units was that we could get from the outside also new contacts, new ideas, also the business units. So it's also kind of a tool for us for communication. It's also for human communication, not technical communication. And yeah, some people were a bit critical to go open source at the beginning, but we found out that this kind of openness where you have in open source is also innovation driver. Because as said, it's a different way of talking. If you say, okay, yeah, just take it, try it out, then, oh, we have to sign an NDA, even if it's not a really critical USB or IP for Siemens. And yeah, the debates here, you need to choose the right way of working. So as said, we had a couple of discussions regarding this foundation stuff. And also you have to deliver quality. And I think we could achieve this, and we are also quite reactive on it. So how we continue? We will continue to follow this approach, that we make upstream contributions or build open source projects wherever possible or where it makes sense and the project allows it. We always have the kind of idea to be a bit more open than maybe the standard way. So kind of if we want to show something and we could ourselves decide, okay, that's not the critical point, then we show it. We will continuously revisit this way of working. That's very important, I think. If this Coaty, for example, would find a use case where it's really also very important to grow this framework, yeah, as said, we maybe go to such a foundation. And as said, we have 2 or 3 more OSS projects already in the pipeline. Go next slide. And finally, I would like to invite you to, we have a nice vision video on YouTube, which shows a bit more about the idea behind collaborative IoT, which we would invite you to visit, and also our website, Coaty.io. That's it.
thanks.
Thank you very much. I have one question here from the chat. Would you recommend starting with inner source to other projects or going directly open source? So what would you recommend to the newbies?
I would say if your project allows it, I would directly go to open source, honestly speaking. Because what is the difference then? If it depends a bit on your, if you're could not decide right now, if it's really something critical to Siemens business, I would keep with inner source. But if you really say, okay, we could talk to the business units and they say, okay, do whatever you want, if it helps, then I would start directly with open source. But you need to have a kind of basic code base which allows you to, you should have a certain quality.
And you had experience already on working on open source projects, contributing to the open source project and so on.
Yeah.
It's not a new, the open source thing was not a new topic for you.
Not completely.
Not completely.
We were not that intense.
Exactly.
But
It makes it easier.
I guess that's another precondition somehow to really have the experience already.
Yeah.
So we have time for one last question here in the room.
Actually, I would have three, but about the inner source thing. So you said you started with inner source. Did you get also contributions from other Siemens organization on base of the inner source project?
Not at this point. I think it was because the guys we were talking at this point in time were either so they were not software developers. So basically were from IT, but not IT software development. They've been industrial engineers who were planning the workflows in this Ambergwerk. No, in inner source we didn't. We had this external project, this CREST project, and then we directly went open source. So it was.
So in other words, it only really started with contributions when you went open source.
Yes.
Yeah.
Okay. Thanks.
Thanks a lot, Markus and Hubertus, for giving us and sharing the insights, especially also on the experience you had on the way. And impressive to see how you were working over the last years. And that's definitely one of the next projects I'm going to do, a Git clone Coaty. And thanks a lot for being here and joining us. And let's have a break.